Hello, psychology students. I have notes today for Module 7, and today we're going to talk about the differences between the brain's two hemispheres. And so we're going to start with talking about how the brain, for the most part, kind of works together when we talk about these different hemispheres. And there's a term, it's called lateralization. This is when we take the right and the left hemispheres and we bring them together to act as one. To do so, we kind of have to understand the functions of both hemispheres. So we're going to start with the left hemisphere functions. This controls, for the most part, our right hand touch. It also is involved in writing, science, our love of speech and logic, language, and finally math. The left controls the right side of the body movement and touch. A stroke in the left hemisphere will cause a loss of verbal skills. Analytic skills for breaking things down so that you can analyze what happens occurs here. So if you take a look at the diagrams that you have, your left brain is kind of like your book smarts, if you want to call it that. It's a lot of the important data about language and math are going to occur here. When we talk about the right hemisphere, this controls the left-hand touch. It also is involved in spatial construction, like how we visualize things. It's also involved in creative thinking, fantasy, art appreciation, and finally music appreciation. The right side controls the left body movement. It also is involved in senses and, for the most part, the visual side of things. The right side has the ability to picture things, and that could be in the form of like an artist trying to maybe draw something, or an architect trying to build something, or if you're talking about athletes, a gymnast maybe being able to visualize where they need to be on the mat when they're doing a tumbling routine, or an athlete being able to visualize where a football play is going to occur, and maybe where to be to perhaps break up a play or make a tackle or perhaps intercept the ball. This side appreciates art and music, but the right brain, for the most part, doesn't know what the left brain is doing, and vice versa. They kind of have their own little thing going for it. And it is possible, because of maybe some type of disability, that the right and the left hemispheres are not allowed to communicate with one another. Okay, there are some gender differences. Women have a tendency to be what we call more bilateral, being able to use both sides of their brains kind of equally. Men have a tendency to either be either left brain or right brain. Women rely on both sides of the brain, both left and right, for verbal and also spatial task. Strokes to the left side of the brain, for the most part, for women, they're more likely to be able to retain some of their speech skills than perhaps a man who would suffer a stroke on the left hand side. Language and spatial abilities. Language is the best example of a clear-cut difference in the functions of your brain's two hemispheres. In most people, language functions are located primarily in the left hemisphere, and a small percentage of the population seem to be wired for language in the right hemisphere, but it's not really sure. One of the things that we do know is that there are two structures that we really need to focus on that are both located in the left hemisphere, and that is the Broca's area, which is actually located in the left frontal lobe. It's involved in understanding language and producing sounds or words. And then the Wernicke's area, which is located in the left temporal lobe. Again, it's dealing with language and cognition and emotion, and we're going to kind of talk about both of these here in just a second. So the Broca's area is an area in the, for the most part, the left frontal lobe. Directs the muscles involved in speech, so your expressive language. Damage to this area, mostly because of a stroke or maybe some other incidental accident that might occur, will result in difficulties being able to speak or with the spoken language, meaning that you understand what is kind of being said to you, but you cannot communicate by making the words that would be able to respond. Okay, and that can be very frustrating for stroke victims, is that they understand what you're saying to them, but they cannot communicate that back. Stroke victim, for the most part, can form ideas, but they cannot turn those into coherent speech. And it's a sad situation there. Or the Wernicke's area, located in the left temporal lobe, is involved in language comprehension and expression. So it's a receptive kind of language. Damage to this area might leave a person able to hear words but not able to comprehend the meaning of the sentences that are created with those words. The right hemisphere houses most of the brain's spatial abilities. So the word spatial relates to your ability to perceive or organize things in a given space, such as judging distance, understanding geometric objects, or packing maybe a car's trunk. If you love games like Tetris, that's definitely relying upon spatial ability because you're trying to put the pieces of the puzzle together. And matter of fact, people who are a little more dominant right brain have a tendency to like things like jigsaw puzzles and Legos and things of that nature because it kind of harnesses in on that right hemisphere's domain. Split brain surgery. Now, I mentioned before, it is possible that the left and the right hemisphere might have to be severed as a result of some debilitating disabilities. And so in the 1960s, scientists were working on a way to treat severe epilepsy, a brain disorder in which a person has uncontrollable seizures. In an attempt to prevent these seizures from spreading from one side of the brain to another, surgeons performed the split brain surgery operation in which they cut the corpus callosum. Okay, if you remember the corpus callosum, that is a bundle of nerve tissue, if you want to call it neurons, that for the most part allow for communication between the left and the right hemispheres. So the corpus callosum prevents the two hemispheres of the brain from communicating if that's severed. And the psychologists that were involved in this were Roger Sperry and Michael Gazzaniga. And they performed this surgery, and they found that the surgery left basically a patient's personality and intellectual ability intact, but it did alter their perception and any kind of corresponding abilities, which was kind of interesting. And so they did develop a series of ways to test how that differed between those people who had the surgery and those who had not. Okay, important things to notice is that information from your left visual field falls onto the right side of the brain or the right side of the retina at the back of each of your eyes. It was cleverly designed by Gazzaniga and Sperry, and they asked that the split brain patients focus on a spot at the center of a screen while the images were projected to either the left or the right visual field. And as a result, it demonstrated some interesting gaps in perception among people whose corpus callosum had been severed. People who have had the surgery know that the left side and the right side of the body seem at times to be under the command of different masters. When there is a conflict between the two hemispheres, the brain, at least the left side, usually tries to make sense of it all. And thus, if the right hemisphere of the brain implements a behavior like walking, the left hemisphere will try to explain the reason for that. Thank you very much.